Hello everybody, welcome back. So as promised, this is the first part of two, I think. I don't think I can get it all in one. I'll do two shorter videos on this occasion. You've seen this previously, the NCC300, and originally I had switch mode power supplies driving this very successfully, no problem at all. But I wanted to move on to the Avondale Voyager variant of this, which is we have a transformer with twin secondaries here. I split them originally. They were paralleled up and just supplying this one Cat 6 module here, supplying the whole board. But now what I'm going to do is split these. What I've done is split these off as independent secondaries here. One is going to supply this power supply module. This power supply module, it could have been, it could be a Cat 6, mini Cat 6. You've seen this before. I did a little video on this. Or it could be another Cat 6. But I just happen to have a few of these knocking about. These are Pinkfish Media Group Buy board, power supply boards, a bit variable in what you can do with it. I've just got some, these are 2200 microfarad 80 volts EPCOS general purpose capacitors. Again, these in the Cat 6 module are general purpose capacitors, nothing special, no exotica here. So one secondary off this big transformer will supply the Cat 6, which will supply this output stage of the NCC300, and this little Pinkfish power supply module is going to supply the front end and the regulators. Nothing difficult about it. I've just got to mark it up, drill some holes, mount this on this chassis plate here. What I'm also going to do in this video is put in a Valmont DC speaker protection module. You can buy these very cheaply. Excuse me. They run off of 240 volts. They're a standalone unit. They're very good. This is a stereo, 2 channels. You can couple these together in this configuration. This is just a mono power amp, and you can run this, if you like, with using just one side of the relay, one channel. So you've got the PA. This is a PA, would be from the output of the amp board, and LS is loudspeaker. I don't know if you can see that. That goes off to the loudspeaker output over here. So I'm going to mount that over there somewhere like that, nice and neat. So the output of this board will go to here, and from there it goes to there, and it comes off the mains over here. And the detection, the 0 volts detection, can come off any 0 point if you like, but I'll probably come off here as a spare spade here. But this spade also has to be coupled to this power supply. Make sure there's no imbalance between the two, but we'll run by that bit of wiring later. So that's the explanation. I'm going to go away and drill some holes. I'm going to go and put some spades on these secondaries, couple it together, a bit of wiring, and we'll come back. There'll be a little bit of setup to do on this front end. I've just got to check that the regulators, these positive and negative regulators on the front end, are balanced and working effectively. You have to remove, there's a little link, I don't know if you can see it, there's a little link here, without using this power supply supplying this here, this regulator. The power comes into this pin here, across this diode and into the regulator, where you can't supply both supplies from two separate power supplies. So this little link, you just pull that link off, and now this is independent from this. So the front end is independent from the output stage. So that will be done as and when. Just a little note, never forget that if you're doing it. Most people that have built these up know that anyway, but it's just a bit of interest. So without further ado, I'm going to go and drill some holes. A bit boring, but the way I'll do this, I've got a template of this PCB which I'll put on here. The holes on the PCB do not line up with a 10 by 10 holes on this chassis plate, so I've got to extend and drill a couple of holes to get this to line up correctly and get it fixed correctly. So I'll go and do that. I'm going to drill some holes again for this and mount this, and then it's just a matter of wiring it all up, test, set up and test. So I'll be back shortly. I've wired this up separately, so as originally this is one secondary winding off this double core transformer, and another winding goes into here. They are both 0.35 at 0.35 thereabouts. So this one produces about 50 volts, this one's slightly less, it's about 47, something like that. And you can see the positive side of this supply, I've done this separately in orange, supplies the positive A of this regulator, and the black goes across to here to supply this negative regulator here. I've removed the links here, one each side. The 0 here, which used to go back to the center on this power supply, now comes back to the center of this power supply, and I've linked the two zeros from here across to here. So in theory it's just one big 0, but to make sure they run in unison, if there's any discrepancy, we just link the zeros together. 0 is 0 in effect. But there's no cross-contamination between this power supply and that's a power supply with reference to this and this 0 here. Other than that, it's quite simple. I haven't powered it up yet. I might run it now just to see how it performs, make sure there's no magic black smoke going to pour out anywhere. Just before I put power on, I always double check. I'm going to go and double check that everything is correct along here with my meter. I'll put my meter on a continuity setting and just double check that all this wiring is correctly in its place. So a quick continuity check. You'll hear the buzzer. You can't see the meter, but you'll hear the buzzer. So this orange wire goes from there to there, correct. This red wire goes from there to the positive supply off of this power supply, correct. This negative supply comes off of this negative power supply, correct. This negative supply comes off this power supply, correct. All the earths are earth 0, so they should all come back to a single point. Yeah. This is the screening. Yes, that is correct. These two earths here, correct. That one there, correct. And the speaker out should be down here, correct. And this green 0 comes back. This is a 0 off of here, correct. So all that is now checked. And I'm quite confident if I turn the power on, nothing will go bang. But you never know in this game because it's DIY. It's DIY. So with no further ado, I'm just, in my mind, I'm just double checking everything is correct, because when you flick the switch, there's no turning back. I've got a couple of LEDs on here, so you'll see these spark up. I don't normally use LEDs. I think I built these a long time ago. These boards, this Pinkfish group buy board 10 years ago, maybe more now, but it's still functional, still proper, still works. Let's give it a go. I think let's give it a go. Okay, we have power on. Always a bit of a tense time at the moment. I'm just going to check some voltages whilst we're here. Come off a 0. So here's a 0. Let's see what we have at this regulator now. 44 volts, absolutely perfect. I don't know if you can't see that. I'll go over and put it where you can see it. You see that? Yeah. So I'm coming off the test point of the positive reg, and we've got 44.6 volts, and we have going in 47.5, 47.1. So there's a nice drop there, so it's actually regular. We know it's regulating. Let's do the negative side. The negative side is 43.8, that'll do me. 44, that's fine. On the power amp side, power output side, we got 47.5 supplying the whole of this. That's fine, that's fine. I'm very happy with that, there's no problem at all. I'm not going to adjust anything, I'm just going to check the bias now, the bias setting, because this setup may have altered the bias slightly, but I'm just going to check it. We'll see. I need another set of leads for that. I'll just swap the leads, bear with me a second. There we go. We'll see what we got on here. I've got a couple of extra long flying leads on here that I can just clag onto for the time being. Let's see. Get on. .4, absolutely bang on. That'll do me. That's absolutely perfect. This will warm up, so we're at optimum really. I'm going to leave it on the bench here for a while, just to make sure it warms up nicely. Slight bit of temperature, it does take a while to warm up. I'm going to give it an hour and I'll come back, readjust if necessary. Speak to you soon. It's been a couple of hours. This dropped back a bit after about an hour, and I tweaked this back up to 2.4. Nice and toasty warm. It's not running away at all, so that's perfect. So now what I'm going to do is drill some holes to fix this Velman speaker protection module over here. I'll wire up to the mains off of here, and then divert this direct positive speaker lead here through this, and the 0 I'd need to clamp onto one of these zeros here. Anywhere will do, any 0 would do, but that'll be good protection for any expensive speakers that this is likely to drive. So I'm going to drill some holes, do a bit of wiring, and I'll come back when I've done that. So we're nearly there. I've fixed this Velman speaker DC protection module onto the chassis. The output of this NCC300 now goes in to one side of this one relay, and it comes out the other, and it goes to the output terminal. The mains I've piggybacked off of the IC inlet over here and laced it through and secured it above the chassis. There's this zero sensing for this Velman DC protection mode, comes back to a 0 point, and I've left this as a separate item which comes back to this. Any one of the zeros will do, but it comes back to this power supply. So we're just about there now, I think. I haven't checked. I've set all this, as you saw earlier in the video. This is set up for 2.4 volts of bias. I did check this on the bench. It's working perfectly. There's a 6-second delay before it lets power through to the output. What I haven't done is check the DC offset. So we're just going to clap this all together so that we can see that everything else is fine. I'm presuming it's going to be fine. This goes to millivolts, and we'll see what we get when we power up. Again, I'm just double checking in my head everything's fine. I was going to this cable clamp on here, I was going to run the mains across, but I've laced it back through all the AC, so rather than come across the top of the transformer. If I have any issues, I can lace it across the top if necessary, but I don't think I will. 0. Right, there we go. There we go. That's fine. We wait, click, and there we have under 10 millivolts of DC offset. That's fine. You'll see this little yellow LED glows slightly. It's not a fault, it actually does that to tell you that it's sensing. If you read the manual, the manual shows you how to set all this up. It's a shame really they don't do a mono version of this. I mean, I suppose I could piggyback both relays off the output to this one mono power amp, but I've never had any issues in the past. And for you can buy these direct from Velman. I think they're about £15, but if you buy them through the normal RS or Farnell or whatever, they're £18 plus VAT. But if you buy them direct from Velman, they're £15 plus VAT. So it's a no-brainer really. I've seen people sell these for about £20–25 on eBay used. I don't see the point in that. But so now all I've got to do now is put the lids on, or the base is off at the moment. Put the lid on. I'm going to leave it for another hour on the bench and then check again the DC offset, and then I'll put it in the system just to make sure it's working perfectly, which I'm sure it is, and then I've got to do it all again to the second monoblock Voyager, which will be just a copycat of this. So I'll have two monoblock Voyagers in two separate cases. Now I might go ahead and do another video on the lines of this, whereby instead of coming off the second secondary supplying the second PSU here, I might well put a transformer here or here somewhere and run a second transformer to supply this second power supply to supply this front end. I haven't made up my mind yet. I have one already built which I've been using for some years, a couple of years, and I just want to listen to see if there's any advantage in doing that, or using this setup is okay. If it's not worth the expense, well, it's all worth the expense, I suppose, at the end of the day, but if it's not worth it, I will stick with these. These, for me, these are sort of keepers sort of thing. They're that good, pointless upgrading. But I might do another video outlining a second transformer, second power supply that feeds just this front end, and I would put these back in parallel to this power supply feeding just the outputs, and a second transformer and this power supply feeding just this front end. Galvanic isolation they call it. I'm not going to get technical, but you can do some reading up about it. So for now, I hope that was enlightening, entertaining. You can do exactly the same as this on a 220 or an NCC300, or indeed any other amplifier that has this a front end configuration. If you can whittle out the circuit, if you're technically minded, you can run two separate supplies, one for the front end, one for the output, and there are sonic benefits for doing so. So for now, I think that's it. I'm going to put this in, and I'll come back with another short little video on my findings as to whether this is as good or different or whatever to my existing Voyager with two separate transformers and two separate power supplies. So for now, thanks a lot. Thanks for watching. Thanks for all your kind comments and your thumbs up and everything. I hope you're all well still in this COVID situation that we're in. Back to work. I drive to work now, and I've noticed the traffic is building and building weekly. So be safe, be well. Hope you enjoyed it. Speak to you again soon. Bye.